Ya. Estábamos resolviendo algunos problemas técnicos, pero parece que ahora... Ya. Buenos días, muy buenos días a todas y a todos. Bienvenido, bienvenida a esta presentación sobre ciencia abierta y ciencias sociales. Vamos a comenzar entonces. Bienvenidos también a la gente que está ahí conectado en línea. Vamos a comenzar primero con una breve presentación de nuestra decana Teresa Matus, y después voy a presentar a nuestro invitado Nate Breznau, y luego él va a dar su charla sobre temas de ciencia abierta. Así que, sin más, le doy la palabra a nuestra decana Teresa Matus.
Muchas gracias a todos y a todas por estar. Muchas gracias, Juan Carlos, por poner el seminario. Muchas gracias por venir a conversar. Yo creo que pocos temas suscitan un desafío tan grande hoy día en la universidad. Yo comentaba con Juan Carlos que vengo de la reunión donde se discutían esto en términos de las estimaciones presupuestarias de la universidad y de los recursos que se requieren para hacer esto. Pero quisiera introducir directamente con una premisa. A mí me parece que hoy día la relación, especialmente de las ciencias sociales con la ciencia abierta, puede entrar en ese desafío de innovación mayor, que es cómo volver a pensar el mundo. O sea, yo creo que nosotros, mediante esta relación, podemos volver a abrir mundos. Y creo que en la universidad esto es tremendamente necesario por lo siguiente. Nosotros tenemos un modelo en la universidad cuya base son los procesos formativos. Y por lo tanto, el desafío de la producción de conocimiento y las formas de entender de los conocimientos es como un subsistema adentro de un cuadro de formación que puede ser interesante, pero que es parcial y sobre todo que es algo de conocimiento de los expertos. O sea, no hay así un ábrete sésamo de lo que se produce allí. Ni lo tienen los propios estudiantes, porque no conocen formulaciones de proyectos, ni lo tenemos en términos de comunicaciones y producción de datos. ¿Por qué? Porque esas cosas están subsumidas adentro de cada proyecto. Entonces, me parece que conversar hoy día en términos de cómo pensar la relación entre ciencia social y ciencia abierta nos puede dar un prototipo interesante para poder conversar con la universidad a propósito de las relaciones existentes entre lo que se produce en la universidad como conocimiento, cómo eso insuma en forma real programas formativos de pre y posgrado y cómo eso se comunica en términos de las audiencias y las agencias. Me parece que además este es un momento en que esto es posible, o sea, las universidades hoy día pueden desarrollar un programa de cambio y abrirse a esta oportunidad cultural. Este es el planteamiento de varias universidades latinoamericanas, donde poder usar como soporte el principio y la práctica de la ciencia abierta. En este sentido, creo que esta relación no solo abrir mundos, sino que abrir la potencialidad para otras universidades, ¿no? Quisiera terminar con algo tan innovador y actual como lo que decía Andrés Bello en 1847 a propósito de la ciencia. En este caso decía, el adelantamiento prodigioso de las artes, el progreso de la cultura intelectual, las revoluciones políticas piden cada día nuevos signos para expresar ideas nuevas. Entonces, en esas gramáticas de la libertad de Bello, me parece que enfrentar hoy día el problema de la visibilización, de qué conocimientos estamos planteando para qué mundo, involucra, y con esto termino, pensar la universidad como quien programa y construir un lenguaje nuevo. Si los problemas hoy día están interconectados, la producción de conocimiento también tiene que estar interconectada. Y podemos tener la aspiración como en la astronomía que se está construyendo en el norte de nuestro país, tal vez el telescopio más grande del mundo. Bueno, ¿qué espejo nosotros le ponemos hoy día a las ciencias sociales en su producción de conocimiento para que también ilumine espacios, comunique espacios, cambie el rostro de las desigualdades que hoy día tenemos tan fuertemente, piense problemas de otro modo y en este sentido nos ayude a este potencial de abrir nuevos mundos? Entonces, profe, muchas gracias por estar aquí hoy día. Este es un camino sin duda que vamos a recorrer, así que espero que este sea uno de varios diálogos, debates, propuestas y ya agencias de implementación de estas formas de relación. Así que muchas gracias a ti, Juan Carlos, a ustedes por estar acá, y desde luego esta es una de las dimensiones sustantivas de lo que nosotros queremos promover en la facultad y también en la universidad. Muchas gracias.
Muchas gracias, decana. Seguimos entonces ahora. Yo estoy en un doble rol, ¿cierto? Acá de moderador, presentador, así que también como moderador me presento, porque no me presenté al principio. Para los que no me conocen, soy Juan Carlos Castillo, profesor de Sociología acá en las Facultades Sociales. Y vamos entonces ahora a dar paso a la charla de Nate Breznau. Les cuento un poco el contexto de esto. Yo creo que nos conocemos hace un tiempo con Nate. Me da la impresión que la primera vez que nos fue en la Conferencia Internacional de Sociología de Yokohama, el 2014, creo que ahí fue, en Japón, y me interesó mucho la agenda que él llevaba por el tema de, sobre todo de política social y preferencias redistributivas, tema del cual él presentó ayer en la tarde en el Centro de Estudios Públicos, estuvo justamente abordando ese tema, que es una de sus líneas principales de investigación, y ahí al menos yo conecto con cosas que hago yo de justicia distributiva, así que encontramos algunas cosas ahí en común. Y bueno, ha sido como para mí una experiencia como muy inspiradora conocer lo que él hace, porque además luego él también comenzó a desarrollar muchos temas sobre ciencia abierta, que es lo que está él presentando hoy día, y hemos mantenido como alguna colaboración del año pasado en la parte de preferencias. De hecho, editamos un número especial en Frontiers, que no tuvo tanta convocatoria, pero igual tuvimos ahí un número de artículos en temas de preferencias redistributivas en el sur global. Y Ciencia Abierta, bueno, yo sigo muchas de las cosas que él hace. De hecho, tiene un artículo bien interesante sobre si es que la sociología necesita ciencia abierta, y que es una reflexión muy, muy interesante para nosotros, muy inspiradora también, porque es muy específico. O sea, Ciencia Abierta es un movimiento, bueno, él nos contará más, pero global, y ya tiene mucho tiempo, pero pensarlo en particular en el ámbito de las ciencias sociales, y más específicamente tal vez en sociología, lleva ciertas particularidades y ciertos desafíos que es interesante, yo creo, como poder discutirlas, ya que qué implicancias tiene, ventajas, desventajas, etcétera. Así que, de hecho, bueno, en ese marco de ciencia abierta, él también nos invitó, tiene un artículo que es, bueno, yo no sé cuánto tiempo habrá trabajado en él, porque es un artículo que tiene un trabajo inmenso, que es un ejercicio de replicación. Yo creo que algo de eso tal vez Nate nos va a comentar hoy día, donde ustedes saben, o sea, parte de ciencia abierta tiene que ver con qué tan transparentes son los análisis de datos y qué tanto uno puede replicar, es decir, o reproducir, ¿ya? Más bien reproducir, llegar a los mismos resultados con los mismos datos. Y él organizó a nivel mundial un ejercicio de replicación, nos contará más, con más de 100 equipos en el mundo, y ahí tuve la oportunidad, digamos, como nos invitó también a nosotros un equipo de Chile, donde estuvimos con Cristóbal Moya, que está acá presente, y Luis Maldonado de la Católica. Así que fuimos como representantes como del team del equipo chileno en ese artículo. Y además, generosamente, él nos incluyó también como coautores de la publicación. Así que no sé cuántos coautores hay, como 100, no sé, pero igual estamos nosotros ahí como parte del equipo chileno. Así que también ha sido muy, muy generoso con eso. Y bueno, o sea, como agradecerle su presencia acá y dando ese contexto más como de dónde viene esto. Además, bueno, un dato, Nate venía acá, de hecho la invitación era para marzo del 2020, invitación, y sabemos lo que pasó. Yo creo que estuvo a punto de subirse el avión como hasta 2 días antes, y era voy o no voy, ya mejor no. Y claro, yo creo que se habría quedado encerrado en Chile por 4 meses, que habría sido un infierno probablemente estar acá encerrado. Así que a pesar de eso insistimos con la, insistimos con la invitación y afortunadamente ahora lo logramos. Así que con eso me quedan solamente un par de credenciales. Bueno, Nate es sociólogo, doctor en sociología de la Universidad de Bremen, trabaja actualmente también en la Universidad de Bremen en el SOCIUM, que es un centro de investigación, ¿cierto?, en temas de política social y tiene mucho de sociología. Y bueno, también yo creo una diversidad de intereses, uno de los cuales es Ciencia Abierta. Y muchas gracias por estar acá. Y con eso entonces le dejo el piso para que pueda ahí presentarnos su conferencia de hoy. Muchas gracias, Nate.
Good. Thank you for this very kind introduction. And also thanks for providing text. I will talk a lot about what especially a lot of you appear to me as early career researchers, and you are very important in the open science movement or have the potential to be, but it also requires people who are much longer researchers and people who are in positions of power where they can influence policies at the university or even larger levels. So thank you for providing that context. My talk will be especially practical. So it won't be so much about my research on things like social policy or redistributive preferences, really not at all. It's really about open science. So with that, let's start. It doesn't advance.
There's a presenter.
Okay, great. Open science is about empowerment, but it's also about tools and trying to make things useful and practical. So you'll notice in the lower corner of the slide, the CC BY symbol. I don't know if some of you know this symbol. Yes. Oh, you don't see it so well here, but this is the CC BY symbol. And so the idea is by putting this here, I encourage you to use these materials if you like them. And I think this is already a sort of lesson in open science. It's about sharing materials to empower other people to do good science. I also have this open science library. It's a Zotero group. Those of you who use Zotero software, you can join the group, and it's a daily growing library of research that's relevant to open science. And just another quick point, Zotero is open source, so this makes it kind of an ideal tool to use. We'll talk more about that. So real practical introduction. So how many of you had heard of open science before today, let's say? Okay, good. So many of you, that's good to hear. So this will just be kind of a refresher or, so basically these are some dictionary definitions of science itself. And it's not so important reading all of them, but they say things like systematic study, observation and experiment, reliable. These are kind of the words that you find in definitions of science. What is actually science? And so because science should consist of these things, if science in practice is reliable and logical and orderly and systematic, then we're good. We don't need open science. So the reason we have something like open science is because I will present some information today. Science in practice is not always these things. And in some areas, it's none of these things. And I put at the bottom of the list transformation. And I think this was also kind of alluded to in the context here, that science, when done well or right, should be transformative. That's not in the normal standard definition of open science, but I like adding this point. I think it's something we should always think about. So adding open and science together, for me, signals the open science movement. And I think it's important to refer to it as a movement, because otherwise it's just another label, right? So the whole idea to have open science is we're trying to get from point A to point B, or we're trying to take science and make it better. And this requires like social movements to create change. This is kind of a social movement within science, let's say. And I encourage you all to join. And the goal of it is that science in practice equals science by definition. So just going over some of the key aspects: open access, transparency, or one might call open process, open source, and open academia. And I'll talk briefly about those. So open access, and Robert Merton, sociologist, some of you may have heard of, actually wrote a lot about this already in the 1970s, and developed what I'll talk more about. But one of those norms is that knowledge should be free and accessible to all. And so that's what open access means. It means that I don't have to pay money to get access to knowledge. It's not behind a paywall, for example. We know sometimes it's a challenge to get journal articles that we need for our research, for example. And the Budapest Open Access Initiative was to say that that goal of open access would be to make everything available on the internet. So this is a very modernized definition of open access. And since we generally publish for free, this should also give us the right to have free access. So there are many papers I've published, and they are, for example, with Elsevier or something, I would actually have to pay to on paper, which feels unfair. And so, sorry to pick on this person, I haven't met them yet, but you see this. There's an article about the open science movement. Oh, interesting, I want to read it, and it's actually behind a paywall. So this is quite contradictory, I would say. So coming to transparency, here we really have to talk about what is a realistic minimum and what's an ideal world, because there's a lot of ideals of open science that we're just not going to be able to achieve. So it doesn't mean we shouldn't try, but a minimum is that all steps and materials used in the research process should be publicly available, right? So this isn't just about that you can download the journal article. What are the data? Where did the data come from, right? So in an ideal world, this would mean all data code and research processes should be easy to follow and reproduce, because sometimes people share their data and code, but it's so poorly organized that it's not very useful. So it's nice if we can share our materials, or if you do qualitative research, you take really detailed field work notes, yeah, that are easy to follow, for example, so you can understand, okay, this is what this person exactly did and what they were thinking, what was the scientific process. Open source is more technical. But any programs or apps or algorithms should be transparent and usable by others. And many of you know what an API is, for example, that these programs should be able to easily interface with one another. So the ideal research tools are not for profit, of course, but many research tools are from profit companies, because sometimes not-for-profit companies don't have the resources to build tools or to build really good tools. So I admit I use a lot of Google programs like Google Docs, because it works really well. And for me, that means they've designed it in a way that could help me or us to improve science. So then it's worth using. And so this last one, this is, I would say, also really important, is the idea of open academia. And these again, especially come from Merton's norms or Mertonian science norms. And that is that science isn't taking place in secret. And this is a problem I will talk more about. By the way, I often teach open science workshops, and they're 3 days long. So you're getting more of a teaser here today. So I did cram a lot of information into these slides, but I don't want to give so much because, again, it should only be a 30-minute talk. But so science doesn't take place in secret, and science is about equality, so that researchers, for example, would get equal pay for equal work. And it's not based on power dynamics that are used to maybe oppress other researchers or types of research. So it should be cooperative, not competitive. And those of you who are already somewhat along your career in science will know it can be quite competitive. Yeah. And another idea, I won't talk a lot about that, is citizen science, where how we as in the scientific community can sort of normal lay citizens to take part in the scientific process to better understand it or to help achieve scientific goals. Okay, so here come the Mertonian norms. Actually, in the 30s, I said 70s, in the 30s already, they were promoted by Merton, studying the sociology of science or the science of science. And I'll just quickly go over them. There's communalism, which was originally labeled communism, but we say communalism now, not that there's this misunderstanding. Universalism, this one is, so communalism is really easy. That one's about sharing, right? And community, no secrets. But universalism is that we are seeking that research would be valid because it's good research, not because of the researcher who produced it, basically. Disinterestedness is that we're acting in the pursuit of knowledge. We're acting with scientific goals in mind. And then organized skepticism is about that we should interrogate the claims that others are making as scientists. We don't just assume, oh, this must be right or not. We engage with it and we systematically try to test if we can rely on the claims we're making as scientists. So now to give some information. So, well, in the publication process, scientists are very quick to report strong results. So you can see these bars here. Dark is the results of research that was never even written up, like in a report. The red is written up but unpublished. The orange is paper in a non-top journal. Okay, we could argue about what that exactly means, in the paper in a top journal. And so you see, if you have strong results, the scientists are much more likely to report them, right? Whereas if you have null results, a null result means you didn't find the effect you were hoping to find, let's say, most of them are never written up. And so this already biases, so if this is a picture of knowledge, we're biasing ourselves of what we think is the truth, because we only get, or we're more likely to get certain results presented to us, the consumers of knowledge, as truth, and other results not. And this creates a problem of bias in the publication process. And what's interesting is when you ask scientists about their practices, many of them either aren't aware that the practices are problematic or admit to taking part in some of these what we would call QRPs, which are questionable research practices. So this is from a survey, and you can see things that scientists do. These were actually psychologists, but failing to report all dependent measures. Collecting more data to try to get certain significant results, right? And the self-admission rate is the dark bar. So 78%, 72% of those responding in the survey said, yeah, well, I've done these practices before, yeah? And then you have some really questionable ones like rounding down p-values. So we'll talk a little bit more about p-values, but so their p-value is 0.051 or something, and they say, oh, I'll just make it 0.049, like literally just changing it. selectively reporting studies that work. That's like the last graph I showed you. And, but here's one that's really sort of shocking. Many scientists themselves admit they fake data, they falsified data, they put in numbers or changed the data in a way to produce some kind of results. And now the reason you have different bars on here is that you ask the scientists, did you do this? And then you also ask them, do you know that your colleagues are doing this? And so based on this, we get a clearer picture of that maybe 9% of psychologists, at least in this survey, are actually falsifying data. So for me, this type of why I would say I consider myself a part of the open science movement, because this is just egregious, let's say, for lack of a better word. So there's a lot of talk that you've maybe heard about is there a reproducibility crisis? Is there a replication crisis? These are terms that are being thrown around in the literature, not so much yet, we could say, in sociology, but especially in other scientific literatures. And basically, again, coming back to Merton, repeated testing to form a set of results trusted as communicating accurate information about the world. So in other words, testing and retesting. And so retesting means replication. I'm going to redo an experiment. I'm going to ask a new sample the same question and see if we find similar results. Actual replication rates are hard to measure, but they're less than 1% in most disciplines and even less than 0.5%. So let's say we have 1,000 that constitute our universe of knowledge. Only 2 maybe, or 3 would be replicated. And so we'd have, you know, all these studies that constitute our body of knowledge, and yet no one has gone and checked, hey, does this hold? You know, what about this? Can I replicate these results? Even did they fake data, right? This could be something that's the purpose of a replication, to figure out if people were cheating, so to speak. And some studies, and again, so this one is in political science. So if you look at the top one, AJPS is American Journal of Political Science. And they did something really great for open science. They started checking all the code. So for studies that had quantitative statistical results in them, they had to submit the code and it had to run. And none of it ran the whole first year they did this. They had an average of 2 interactions. So they had to go back to the authors and say, it doesn't work, can we figure it out? And the authors would say, oh, here I made a mistake or changed this, and they'd send it back, and then it still didn't work, and they'd send it back on average twice. Another study in the journal Cognition, which is kind of like neuroscience, even with author assistance, 37% of articles had at least one effect that was not statistically reproducible within 10% of the original. 37%. And this other study by Stockamer found that 1/3 of effects in public opinion research could not be computationally reproduced. So they take the same data and the same code and would get a different result. And except 1/4 could not even be checked because the code was so poorly organized. There was this open science collaboration, and they repeated a bunch of sort of famous experiments throughout history, experiments which we really rely on to provide our useful knowledge. And there was only about a 30% replication rate of the results that were found in those experiments. Part of why we have the open science movement also has to do with some really shocking scandals. So I would say, to me, it's shocking to survey scientists and find out that maybe 9% falsified data, but scandals were incredibly shocking. So maybe some of you have heard of Dietrich Stapel. He's this Dutch social psychologist, and he basically spent his whole career faking data, and he got millions and millions of euro in money, and he had all these people working for him and supervised all these PhD students, and all of his articles were retracted basically because he had faked the data. He had never conducted the experiments he said he did, or he did the experiment and then went and changed people's responses to questions. It was just incredible. And this was, he was found out around, I think, 2011 or so. And so this was like a really big moment in the history of the open science movement, especially in the social and behavioral sciences. And there was another psychologist, Daryl Bem, who conducted all these experiments kind of on the side of his regular work that proved, or he said would prove, that ESP exists. So extraception, so precognition, like as in one could predict the future, one would know the future, what's going to happen. And what was interesting about this study, it was published in the top social psychology journal, and it used the same methods of every other study. So using the same methods that are standardly used to produce this type of knowledge, he was able to publish this result. And I think in a way he was making a point. And the reviewers basically accepted the paper because it had p-values that were below 0.05, and it described its methods, and it passed what at that time was the bar for getting something published. Some other scandals, I probably won't talk too much about them because I'll end up using up too much time, but we've had some interesting scandals. If you have a chance to look into it, I'll just mention the bottom one. The grievance studies was really interesting. A group of authors got together and wrote articles of what they understood to be something like grievance studies. And they would do things that were, they would make up methods, and they would make up arguments, and they would copy things like from Hitler and put it into the paper. And they got several papers accepted at many journals in this area. And in a way, it was partly an attack on these areas of science, because for them, they were seen as being very unreliable or sort of constructed somehow. I think in open science, we have to talk about p-values, because p-values are increasing over time. People are more and more relying on p-values. And p-values, again, in experimental or quantitative social research, are they've become the gold standard for judging if something's important. So if you got a p-value below 0.05 or a p-value below 0.01, then, oh, it's important. But this has been true in all areas of science, that over time, p-values have become more prevalent. And not sure if you can read that so well, but this was a survey that some researchers did asking students and professors if questions about p-values. So they would ask questions like, you have absolutely disproved the null hypothesis, that there's no difference between the population means. You have found the probability of the null hypothesis being true, and so on. And you could read through these, and I admit myself that I got a lot of these wrong when I started on this process. And that made me and so did a lot of other researchers, even professors. They were not clear what a p-value is. And yet this is the metric we're using to judge our own research. And yet many of us can't actually accurately say what a p-value is. All these statements are in fact false. They are not true about p-values. So just real quick, what is a p-value? It's almost always, there's different ways to use it, but it's a statistical test result used to evaluate the null hypothesis. So it's a form of what's called null hypothesis significance testing. And what it really tells you, what is the probability of observing the data you observed, assuming the null hypothesis is true. That's really all it's telling you. Just good to be clear on that. So I really push people these days, because I myself was guilty of it. I have papers published maybe 10 years ago that use p-values, and I myself wasn't so clear on what it actually meant. And you hear there's studies of how people report p-values, and we're reporting it wrong. It's like, oh, p of 0.05, that means there's an effect of x on y. And that's how we tend to report these, and this is not true. It's an overstatement. Okay, more about questionable research practices is we've come up with this term called P-Val, so that people manipulate p-values, or basically their goal before the research even starts is to get a certain p-value. That's like the goal. So instead of, oh, let me try to do good science or knowledge production, it's let me get a p-value. And I can't tell you how many of my bachelor students, we talk about, okay, you know, they're working on their thesis or something, and we say, here, let's set up these models and do this, and run those models, and then let's look at the results. And so they come back the next day and say, I set up all those models you said, but the results are not significant. They're crushed. They want to cry. And I'm like, hey, this is p-hacking. Your results are important. We set up those models. They're important models. They were done right, at least we'd hope so. And so the results matter. We want to know what the p-values are, not can we get a good p-value. And this is one of the core problems of science, I would say, happening right now. And it's tough in sociology because we have a lot of qualitative research, but I think it's good if qualitative researchers are also clear of what p-values are, because often the quantitative and qualitative studies don't speak to each other because they may not understand each other's methods, for example. Just another term to introduce you to if you haven't heard it, it's called Phacking. And this is hypothesizing after results are known. So this is kind of how I was taught to do research. So I have to be honest, some of my supervisors who will remain unnamed were like, well, you got these results, which don't support the theory you were using. So just change your theory, or just change your hypothesis to predict those results that you got. And that the advice was not meant to harm science. It was meant to, how do you get this paper published? That was why I was given the advice. It was, oh, we don't want to know these theories or hypotheses that don't find the result, this result. We want to hypothesize about this result. But this is also a form of biasing science, right? Because we don't know what we're testing. If we just assign a hypothesis after, we are not, why did we actually test? That's the problem, if that makes sense. And here's some information. So 75% of a sample of psychology studies incorrectly reported the results of a negative. 75%. And they automated this somehow with machine learning. It's a pretty cool study, but basically half of 30,000 papers that they gained access to contained at least one p-value, is what that says, that was inconsistent. So p-values they have to, when you report all these statistics, they actually relate to one another. So you could see if the p-value doesn't fit with the degrees of freedom or whatever, right? If that makes sense. And so they found that half of the papers had something wrong in the reporting. The p-value had been rounded, or it couldn't be the p-value from this same data or this study. So these are, at least for me, or what I'm hoping to encourage in you, this kind of mind blowing up emoji, right? Like, wow, how can this be the state of science? And how can we keep going and not pause to talk about this? What good are we doing for the world if we're promoting this type of science? What's nice about p-hacking and publication bias is another term where only certain studies get published because the editors and peer reviewers want those studies. So authors could know in advance and their study published, or authors could be very honest and submit lots of studies, but only certain significant ones get published. And it's actually possible to diagnose this using a p-curve. So just for your information, we have what tools to diagnose these problems. If there's no effect of, let's just say, X on Y in the real world, p-values should be something like the gray line. It's just you just get p-values all over the place. If there really is some kind of genuine effect, the more findings that test X on Y should be shaped like the green one, right? So the p-curve the most findings should have a lower p-value. Of course, there's going to be variation, but most findings should have a lower p-value and it should decrease. And then here it is happening, you get a distribution like this. We're right at 0.05, or sometimes in sociology, we have really big survey samples. So we might instead be using like 0.01 or whatever cutoff we're using. You will see this gap in the studies, in the literature. And this is evidence of that there's p-hacking or publication bias. And there's studies that I'm not going to show you here, but that have been doing that now. And you can see there's this special jump right around the p-value of interest in a lot of these studies. I think I only have like two more slides, so I'll wrap it up. But what I want to also offer some solutions. So how can we move beyond p-values to increase reproducibility, to improve science? Well, rather than testing the null hypothesis, we should start testing substantive hypotheses. So that would mean I predict, because I have previous studies or I have a strong theory, I predict that, you know, the difference in pay between men and women in such an area should be this big, or I predict an effect of X on Y of this size, and then we should be testing those. Not what we're really interested anyways. If science is just, oh, does X have an effect on Y? It's not very helpful. We want to, well, is it a big effect? We want to understand the effect if we want to understand how the world is working. And so, yeah, so size of effects matters as well. I think I'm over time, so. So the solutions are basically the Martinian norms. So we want to search for knowledge. That's our job, right? Although I admit, right, as someone fit career, I'm also searching for a good position and funding and et cetera. So we have to really try to weigh these issues against one another, but we should be rewarding people who seek knowledge rather than, you know, publish or perish, as we like to say. Promote transparency, promote replicability, and be really open to communicating about this. We need to have the communications across the hierarchy, across disciplines, and it's going to happen in baby steps, so small steps, but it needs to happen. Otherwise, we would say, like in English, running on a hamster wheel, going nowhere in science, right? So, and I would feel bad if I retire some day and look back and think, I didn't do anything useful for science during all this time. I think that would be the point. And that's it. There's citations on that. So thank you for your time.
Muchas gracias, Nate, por la interesante presentación. Tenemos ahora entonces unos minutos para preguntas, comentarios del público. Va a estar acá con el micrófono, así que si alguien tiene una pregunta, puede levantar la mano y entonces ahí le respondemos. Responde Nate. Ahí, Nicolás. Bueno, creo que va a tener que venir acá adelante, superar la timidez y pararse en el escenario y hacer la pregunta. Vamos, Nico.
Bueno, hola, muchas gracias por la presentación. Me quedaba una duda porque en el centro que trabajamos juntos con Juan Carlos, yo soy profesor de sociología también de acá al departamento, nos entregan un puntaje adicional si es que nuestros proyectos incorporan criterios de Open Science y está pensado en el fondo para promover la ciencia abierta, ¿ya? Sin embargo, me pasa que yo hago sociología, pero investigación más cualitativa, y me daba la impresión que algunas de las cosas que se proponían, o de lo que yo conocía hasta ese momento de ciencia abierta, era más fácil, así lo veía yo, de aplicar para la investigación cuantitativa que para la investigación cualitativa. Y ahora, insisto, eso yo teniendo un conocimiento muy rudimentario en general de qué era la ciencia abierta. Y ahora escuchándote, claro, también muchos de los ejemplos que ahora pones vienen de la investigación cuantitativa, entonces te quería preguntar si dentro de la investigación que tú has realizado al respecto, avanzada está la reflexión en la investigación cualitativa o cómo se podría avanzar más en ese aspecto, en el sentido que, por ejemplo, es más difícil hacer disponibles los datos, es más difícil, los mecanismos mediante los cuales uno interpretó los resultados están menos estandarizados, entonces quizás es más difícil la replicabilidad, bueno, etcétera. En el fondo, que pudieras profundizar un poco desde el punto de vista de la investigación cualitativa, si es que la conoces. Eso.
Yeah, thank you for your question. And there is the very strong and possibly real fear that open science is a way to further disadvantage researchers working with qualitative methods. And so this is something we should definitely not promote, in my opinion. If we're really doing open science, it should be inclusive and it should work for everyone. And so the open science movement that I know of isn't saying all qualitative studies have to share all their data. In a lot of cases, this is unethical, actually. And in a lot of cases, it could risk the participants in some way. So for me, it would be really just about being able to be transparent about the goals of the study, maybe in advance, for example, and being able to document, again, there are many different types of qualitative research, but to have some kind of fieldwork notebook or something about the coding, if you did some kind of coding in your research, this type of information is what needs to be shared. And I think in a lot of top journals that tend to publish qualitative research, they do demand quite a high, I think that's a simple argument. So I think it's a misunderstanding, but unfortunately, this fear is real. There are some who would use this to further disadvantage, you could say, those working with qualitative methods. But what I will say is it should become almost as difficult to produce good quantitative research as qualitative research, because now that you saw that none of the code ran, right? And basically what that means is they were doing things very quickly and in a manner that was, yeah, fast, but not good. So to really produce like really good code and to really have reproducible data and have things be presented in a way that's very clear to everybody that really follows the research process is a lot of work. So I think depending on the study, it could be as much work as a qualitative, very well annotated, or however, again, there's many different types of qualitative research. But yeah, I think this is something that should always be taken seriously. But if it's a policy question, I would say you shouldn't lose this point because you didn't share your qualitative data. If your university uses a system with points for sharing data, you should get it for the process. So if there's just a lot of times where you can't share the qualitative data, and you shouldn't be negatively managed or incentivized to do something unethical because it would be bad for the participants. So that could be an unfair system. I don't know how it works, but yeah. I would say one more thing. I think people who work with quantitative or qualitative work with the other type more often. So like I do a lot of quantitative research, but I should do more qualitative research actually, if I'm really interested in knowledge production and also creating bridges, right? We have sometimes a strong boundary between those we even use these labels. Oh, I'm a qualitative researcher. I'm a quantitative researcher. I don't like these labels. It should be, I work with certain methods to answer certain research questions, and some methods are appropriate for question A versus B. So thanks.
Bueno, profesor, muchas gracias por la charla, por el espacio también. Mi pregunta es, desde su perspectiva, ¿cómo se puede superar? Porque en el fondo las culturas académicas también, digamos, son sometidas por décadas, o han sido sometidas por décadas a esta lógica individualista, ¿no? Digamos, como el self-made man de científico. Entonces, ¿cómo se supera, según su opinión, este individualismo que puede tener algunos académicos respecto a temas de ciencia abierta? Decir, estos son mis datos, yo los saqué por mi esfuerzo, etcétera. ¿Cómo superamos quizás como ese cambio cultural? Y también podemos mostrar a esos académicos que esto no es solamente una cosa normativa, sino que también la ciencia abierta tiene beneficios, evidentemente, para todo el quehacer científico y todos los que lo involucran.
Yeah, so I mean, the last point, I guess I'll start with first, which is if our goals really are to produce reliable knowledge, then it should sort of answer the questions, right? The practices we're doing now make science unreliable, basically. And what was the first point again? Can you say it one more time?
En el fondo, el efecto de esta cultura académica que ha venido, digamos, sosteniéndose y el individualismo que pueden tener ciertos científicos respecto a sus datos. Por ejemplo, estos son mis datos, yo los generé, ¿por qué los voy a tener que abrir?
Yeah, sorry, I also need to take this out when I'm talking. There's a discussion in the European Commission right now, which is how can we reward people equally for having produced data? So this should be exactly, right now we're really still in this culture of publish or perish. And so if you produced really useful data, this should be worth 3 publications, or it should have some really high level of value as in the process of assigning merit or rewards in the career, I would say. Just like teaching, we should also find a way to reward teaching. It's very hard to quantify. That's part of the discussion going on in the European Commission, but how are we going to produce better knowledge if we can't, train future scientists in a better way? Yeah.
Voy a hacer una antes y cerramos con la tuya. I think I'll just go in English, so you don't have to put in this in and out. I have 2 questions, actually. I mean, I have plenty of questions, but I'm going to say just 2 for the sake of time. The first one is about, very brief, would you say that one of the risks of this open science is could be also like decreased trust in science? Because, there are a lot of scandals and hacking and so on, so that people that inside the academic communities and also outside can start, distrusting science even more. And what are the consequences of that? So that distrust of science. And the second would be, so how do you see, let's say, the development of open science in the academia in 10 years or so? I'm asking because I think that there are some people that are like you, for instance, that are advocates of open science. And I've met some of them also here in Chile, but seems like a very individual motivations about you are convinced of the Martinian principles and so, and it makes sense. But I would say that most people really, I wouldn't say that they don't care, but they say, oh, that's nice, but I mean, I will keep just doing the things the way I always have done it, because it's too much work and it implies a lot of tools and repositories. So, okay, so I agree, but I will do just my research the way I do it. I mean, all the time, even though some agencies are starting to make, some mandatory commitments for grants and so, still, I think, I wouldn't say people don't care, but I think I wouldn't say that, in the years that I've been more aware of this movement, I wouldn't say that, oh, there's now more commitment in the community. I would say it's the same people as you. I mean, it's always, it's like, it's not really, I don't see a really big change. So how do you see this is going to be a real change in open science, like, let's say in 5 or 10 years? And if so, how would that happen?
It's possible to change. So psychology, where especially big scandals became public knowledge and really affected the trust of the public and policymakers in science. Psychology changed in response quite dramatically in the past 10 years. It's not ideal. There are still a lot of sort of older professors who I'm just going to keep doing things the way I'm doing. But part of why they changed was because of the incentive structures, right? So if it's suddenly required, if open science or better science is required to get published in your journal, in your field's journals, this in a way sort of forces people to do better science, because that's what we're still in this kind of publish or perish paradigm. And so by changing the incentive structures, we can see change. Incentive structures change dramatically? I'm not sure. They have in psychology to some degree. And so you have, as far as I know, especially in the teaching of young psychology students now, they're doing things very differently. And this is a big issue about this, about open science. That's why my experience in sociology is it's not so strong. We haven't really changed the incentive structures, but there are new journals appearing. Sociological science is quite a good one. And yeah, they're starting to have plans for how they would make certain guidelines for sharing your data. The American Journal of Political Science, where they started checking your code, this, I would say, had a huge positive impact on science, because now they know for sure all those studies results are at least computationally reproducible. And it turns out from all these other studies, that's not true. That has not been true in the social and behavioral sciences, probably also not in the hard sciences as well, but that you couldn't just come to the same results by, running the same tests. So, but we have a long ways to go, but teaching is big. So if you're like one of my students, I try to say stuff about open science as much as possible. And yeah, some people who are in positions where they might run a graduate program or so, they can invite speakers to come in and talk about open science. I mean, it's like, what are we doing here today? Hopefully just raising awareness is always the first step. And again, that's the last slide says baby, but that's an important one too, just to be aware of this. I don't know how much intrinsic motivation people would have. For me, it was just like, I would almost feel guilty if I kept doing research the way I was doing it before. Like I couldn't sleep at night because it's like, this is producing useless knowledge that's only there to try to get me a tenured professor position. And I just couldn't feel okay with that. So.
¿Tenemos una última pregunta, Javier? ¿O... ¿Sí?
Voy a hablar en español. Primero, muchas gracias por la presentación. Bueno, más que nada mi duda tiene que ver con la idea de publicar en revistas donde no cobran por poder ver esas publicaciones, entendiendo que es ciencia abierta, y desde mi posición como estudiante. Como estudiante tengo el sueño de ojalá poder dedicarme a la investigación y a la educación como mis profesores aquí presentes, y para llegar a esas mejores universidades o mejores centros tengo que tener carrera, y parte de esa carrera es publicar en revistas de mayor estatus que indican que mi investigación como tal tiene más peso en la comunidad científica. Quería saber si es que es posible para mí, como alguien que todavía no tiene nombre en el mundo de la investigación, poder desarrollar mi carrera en haciendo ciencia abierta y apuntando a llegar a estos lugares de mayor estatus.
Yeah, that was something I didn't really cover here today, but there's what you might call an in-between solution. So yes, the incentive structure is still, if you can get a top journal publication, this is the best thing you can have to try to further your career. And many of these are not open access journals. So there's a kind of in-between step, which is to use preprints. If you've heard of this concept, preprints are where you're put the working version or a lot of journals actually legally allow you to put just the very last version before the final proof online and share it, not for profit, of course. And there's Soc Archive, for example, is the kind of sociology preprint server, and you can access it through what's called the Open Science Framework, or OSF. And so what happens is you put your paper there and you can link it to the DOI of your top publication that I hope you sort and then people who are paywalled, because this is especially big in middle and lower income countries, for example, not having access across these paywalls, they like Google or whatever else could redirect them to this working version of the paper. So they would click on the regular version. Oh, it's paywalled, I don't have it, but somehow, especially Google Chrome is quite good at this. It'll show you your access options. So if you use Google Scholar, for example, again, I know Google is a large company and we can say many things about it, but I find Google Scholar works quite well. And so I do use some of these things. So, but preprints would be a in-between solution to this problem for right now.
Ok, muchas gracias. Entonces, con eso estamos dando término a la presentación. Quiero agradecer nuevamente a Nate por estar acá, por haber venido a Faxo a hacer una presentación sobre este tema, que nos deja, yo creo, muchas preguntas, muchos desafíos. Sabemos que el avance de la ciencia abierta no es algo, no es muy fácil, requiere bastante conocimiento técnico. Yo creo que es algo que de todas maneras se viene y hay que estar preparados para poder abordar todos esos desafíos. Hay, no sé si sabes, la NIT tiene una política ya bien clara de temas de apertura. Están estos proyectos de investigación, los INES, Ciencia Abierta, entonces igual hay un desarrollo, está andando rápido. Y yo creo que tenemos que, como decía Nate, claro, como comenzar por un primer momento tal vez como de concientizar un poco, dar a conocer de qué se trata. Y también ir aprendiendo. Si igual uno en la universidad finalmente nunca deja de aprender, o no debería, creo yo, no es el lugar, digamos, para estancarse, sino que para seguir aprendiendo cosas nuevas y enfrentarse a nuevos desafíos. Así que me parece que esta presentación es como muy, muy importante para nosotros como facultad. Muchas gracias, Nate, nuevamente por haber estado acá, por haber venido. Y también aprovecho de terminar con otros agradecimientos. Agradezco también a COES, que cofinanció la traducción de este evento, también al Fondesit de Educación y Meritocracia, en el cual estoy yo y que también es parte del financiamiento de esta visita. Y también un agradecimiento especial a Kevin Carrasco, que es asistente COES, que está sentado ahí y que estuvo ahí trabajando hace tiempo en poder coordinar esta visita que está llena de detalles. Así que muchas gracias también, Kevin. Y gracias nuevamente, Nate. Muchas gracias.